Hello again, 'tis yourselves! Thank you for joining us again here at Intel's Mini Scientist, where we've been working scientifically and exploring your world of science, technology, engineering and maths. I am still Phil, and yet again we're going to bring you another lesson, experiment and chat, step by step. And I'm sorry to say that sadly, the jokes have not improved. What has improved, hopefully, though, is over the past few weeks, your STEM skills have gotten better because you only get better with practice. So the more that you do and the more naturally curious you are, the better you get at solving problems, answering questions, working in teams, and basically using what you've learned to make your life easier. That's what science, technology, engineering and maths is all about, being cheaper, faster, safer, cooler, more sustainable and more ethical. It's up to you to decide what you create, and that includes your future. There's potential in us all, and the Intel Mini Scientist is merely a part and perhaps even a start of your journey to greatness. I personally guarantee that it is in our nature to be curious, to innovate, to create, and come up with great ideas. Sure, didn't someone in your family invent fire? There was that biscuits. Either way, today's work is all about the environment and how we can take inspiration from it, because generally, if we're looking for a solution to a problem, the answer is in our nature. So today we're looking at environmental awareness and care. We always want to come up with the best and the brightest new ideas, but we also want to have a healthy planet to use them in. We're looking at being inspired by our planet because the world that we live in is a wonderful place, and it's the biggest research lab that has ever existed. Our Earth has evolved over billions of years, so why not copy it when we're coming up with new systems to make our lives easier? In our experiment today, we'll use natural resources to see how we can sustainably clean water without damaging the planet. We want to see how our planet works, learn from it, and then figure out the best ways to look after it. Sustainability is all about the environment, people, and the economy. And often when people hear the word economy, you just think about big business and making money and nothing else. But as citizens of Ireland and the world, it is important for you to figure out what you really care about. So when you're working for, you've got your own company, you can choose to make decisions that not only look after the planet, but are in line with what you believe in. And you get to choose that. And people will listen. And you'll be able to explain it all because you've got science at your side. Tried it, tested it, trust it. Well, why not? Want to do an experiment? Come on. In this experiment, the class will learn about soil erosion and how plants play a vital role in protecting soil from the effects of rainfall, flooding, storms, and strong wind. Not the strong wind that comes with beans, but actual strong wind. Things like oceans, waves, wind, water, and ice are all constantly eroding and weathering the surface of the Earth, changing the land around us, which is why it's so interesting to look at. Why don't you and your buddy take a look at some pictures of glacial valleys, deserts, landslides, river deltas, but also look in your local area, like what's around. If you live near the sea, how has the sea eroded stuff? If you live near a river, how has that pushed through the land or taken stuff away? Like the reason that the sea is salty is because minerals have been washed away from the land into the sea. So ask yourself, think about these things. Where did these features come from? How did they come about? Did you know that these features are all the result of different kinds of erosion or wearing away? Glaciers have been created in spectacular valleys and glacier lakes. The sands of the desert are spread by wind and can make it grow in a process called desertification. River deltas, like where they split out, have many different channels and islands created by flowing water that erodes, wears away, and deposits rock, sand, and clay, creating unique and pretty patterns. In the same way that I can gladly erode away a giant tray of biscuits, land can slowly be worn away too. Erosion is a natural process which sees rock and soil slowly broken down over time. But human activities and climate change can speed this process up and damage the environment. So the first thing is, I want you and your buddy to think of a landslide on a steep slope. So picture it in your mind. Think of it. Observe, look at it in your mind and think what? What causes it? Some natural factors that might contribute are if the slope is really steep, if there's heavy rain, strong winds, but human activity like deforestation, like the cutting down of trees and the cutting down of their systems, the roots that not only suck up water, but also help keep hold of the soil, keeping it together, leaving the soil vulnerable to being washed away. On top of that, climate change is causing more extreme weather events that can make the problem worse. But fear not. Nature, like with everything, usually has the answer. The roots of plants hold the soil together better than any human-made structure and can protect against desertification, the cutting down of trees, storm surges, landslides, and the washing away of soil into rivers and the sea. Today, you lucky people, we will simulate heavy rain on soil and see what happens. You can even use earlier on you saw the wheatgrass that we grew, you can use that as part of this experiment. So things are like these lesson plans. We take you through them step by step, but it's up to you to set up your plan, ask questions and take the time. You don't have to follow along at the same speed that I'm doing this video. Explore and find out what way you want to do these experiments and where your interest is. In this bit, you're going to make 3 simulations of soil systems with different amounts of plants and organic material. This material helps hold the soil together, it grabs onto it. So there's less of it there. And the less of it is there, the more unstable it is. And the more vulnerable it is or likely to be washed away by running water. So for all of this experiment, and it's in your lesson plans and if you need it, you'll need plastic bottles, 2 litre or 1 litre, three of them. You can get these from like the bin or someone's throwing them out, but you generally don't buy them. Get ones that are being thrown out or they're going to be going into recycling anyway. Get some soil, some sods of grass with the roots intact, or use like we were growing earlier on. Look, these are our ones from wheatgrass. Now these are only a few days old, but if you leave them grow for a few weeks, then you can use that in this actual experiment. You will also need some leaves, some moss, some small twigs, some water, a little bit of string, and filtration materials. Now that's a big word, but what we actually mean is like stones, gravel, sand, and clay. So you've got your wheatgrass, you've got your other bits. You're also going to do what we've been doing over the other weeks in the experiments, is that procedure. We've got a problem, we want to stop landslides. We're going to do our little bit of tests, we're going to do our experiments, but all the time we're recording, we're writing down, we're working as a team, discussing things with each other. So you're going to record these things down on a sheet of paper. And we're going to do 3 different tests. So we're going to do column 1, column 2, and column 3, or bottle 1, bottle 2, bottle 3, and you're going to put different things into them. The first thing that you're going to do with these bottles, and you may need help with this, is when you get the bottle, you're going to cut a section out of it. So kind of like the top layer that you can see there has been cut out. And you clean it, get all the sticky stuff out, but this is what you're going to let out. Now for the first bottle, what we want you to actually put into it is the soil. So I have some soil here, and I'm going to take some of this with a spoon, and I'm going to just put it into this bottle. And what we're doing is we're mimicking or making a model of different types of land. So some land used to have lots of trees on it, and then they were all cut down and the roots die or they get pulled up as well. So you're just left with the soil. So in this, I am putting soil into this here. I'm going to pat that down a little bit and put it in. Actually, I can probably pour this in. And you will take the time to do this. Also, try and make sure that you're not creating too much of a mess. But this is effectively what you're left when you have all of deforestation. You've taken away all of the plants and trees. So I'm going to leave that there. The second one that we're going to have, and I've already started this one, the same thing, you've cut away the top. You're going to put some, so I'm going to put some more leaves into this one that we have up here, the bits we prepared earlier on. So in this, you've got your soil, your leaves, your twigs, your moss, your rocks and gravel. So a little bit more life that's in it as well. So there's still a little bit more that's in this than in, or there's still a little more. So you've got little bits. So no trees necessarily or plants, but you've got kind of little bits of twigs of where there used to be stuff. Okay, so we put that there in the middle. That's number 2. So we've got in the first one, soil, and you can record these on your own sheet or you can use the one that we've supplied with the lesson plan. So we've got soil, the second one we've got twigs and filtration, and then in the third one we've got our sod. So the sod, like I said, can be the one that you've already made yourself with the wheatgrass, and the good thing about these is they really knit well together. In fact, you can see, even though it's been 3 or 4 days, you can see their roots. See, the roots are coming through. It's actually we're quite proud that we've grown these things. So over 3 or 4 weeks or 2 weeks, you're going to get a nice high crop that you can put and use in this. Or you can take something like this, which is a side cut of what we have here, which is a soil sample. You'll see that the grass is there and how the roots go through. And it's that root system and the compacted nature of the soil because it's there that really helps. So we've prepared this already here. We've got the soil. You'll see it's the same section as that there, and that's going to sit over here. So we've got bottle 1, bottle 2, bottle 3. Soil, filtration, gravel bits and leaves, and then sod in the third one. Now, what we're also going to do is we're going to add water to all of these, and there's openings here. So rather than it just spill out onto the table, you can either go back to your recycling and get another bottle that's normally going to be thrown out and put 2 holes in it. You might need a little bit of help in it with that, and then you'll put thread through, you'll tie a knot on each side, and then you'll hang these over. Because what we have them here, we had little beakers, so I'm just going to hang these off here. So on bottle 1, I'm going to hang this off here. You'll see what we've done is we've just put an elastic band around it. You could use a cup. Like I said, you can use the plastic bottles. It's important that you reuse stuff as much as you can. All the way through all of these lesson plans, we're trying to be as responsible as possible to reuse things and to make sure that we don't waste anything. So now you'll see bottle 1, bottle 2, and bottle 3. So I have soil, twigs, and everything. Now, what we're going to do is we are going to pour water. You've seen this before. And we're going to slowly pour it into each of these bottles. And it is then going to flow out into this. And what I want you to do is to make a prediction of what you think the water is going to look like when it comes out the far side. So we were talking about landslides and erosion, like what's going to be taken with it. As water flows, what comes with it? So we're going to take a bit of water, pour it slowly into this one, pour it into that one, pour it, and see what comes out. So in our columns along this, we want to make a prediction of what we think is going to be the cleanest water, I guess, because it'll have the less bits washed through it. Is it going to be number 1, where there's no leaves or anything else in it? It's just soil. Is it going to be number 2, where we've got the filtration bits, it's got leaves, it's got twigs, it's got bits of gravel? Or is it going to be the third one that's got the sod of grass with the soil and the grass? So in this, make a prediction. What do you think is going to be the cleanest, what's going to be the next cleanest, and what's going to be the next one? So I'm going to write down, I think, I don't know. What do you think? Have a chat with your buddies, see what they say. Like, this is what it's all about, making predictions, having guesses, but not just wild ones. Think about what we've seen before, what you've observed in your life. Think of where rivers are. Think of what flows into them. So I'm going to go with, I think the soil is going to be the dirtiest. I think the sod is going to be the second, and I think the twigs are not going to, I think the water is just going to flow over it. Okay, so we're going to do it? Right, okay, so let's see. We're going to take our first bit of water and we're going to add it into here. I'm not going to knock it over. There we go. So we're adding water into this. It's slowly, now you have to do it enough so that it fills out so it starts pouring out the end. Oh, there we go. So water's falling out down the end. I should pour out now. Okay. So it's pretty manky. Yeah, you can see that a lot of the soil has been just washed straight through, which is exactly what erosion is. You've got all those bits been flowing through. So what do we think is going to happen now when we add this water into the middle one, which is the leaves, the filtration stuff, the kind of what you'd imagine, like the gravel, the dirt. Now, okay, it's still taking up a good bit as we pour it through now. Do I need more water to get into this? Probably need a little bit more. So if I add this in, ooh, very gentle. Ooh, sorry, I should have done it slowly. Okay, there we go. Nice, slowly pour. Now, oh, have I added too much? Is this gonna pour out? Have I measured it? Okay, that's underneath it just in case. Or have I measured it perfectly? Surely not. No, I definitely couldn't have. There's no way. It's going to spill out. I know this is not exciting for you, but it's exciting for me. How did I measure this perfectly? Surely. Don't spill. Fantastic. This guy, can't believe I did it. Nailed it. Okay, so last time. What do we think is going to happen? So I'm going to pour in again slowly into this from the back. Here we go, pouring in water into this. It's taking up a good bit, actually. Okay, here we go. Pouring water in, pouring water in, pouring water in, pouring more water in, still pouring water. There we go, it's starting to flow now. Here we go, I can add more in. Okay, oh, maybe not that much. Okay, I'll pour a little bit. Here we go. Hey, okay. Good, look at this. Okay, so far, We've got pretty dirty, manky water where the soil has been washed through. We've seen that this is brown. It's not as dirty as the other one. There's a couple of bits, but really it's kind of the brownness of the water that's been kind of washed through all of this. But the last one with the sod, that's pretty clear. Like I wouldn't, like if I got that in a glass, I wouldn't be like worried. I think that looks like, whereas I wouldn't drink that. I definitely wouldn't drink that. That I'm not going to drink, but that looks pretty impressive. So with my predictions that I made earlier on, I said the soil was going to be to have the most stuff in it, was going to be the dirty. So we can check that off there. Then I said it the other way around. I actually thought that the water would just hit the leaves and fly off, whereas actually there's bits and there's kind of dirt and that's been washed through it. So it's the other way around, whereas this is the clearest. Okay, so that's 2 and 1. So that's interesting. I like that. So from this, you can see that maybe that plants act as a natural glue for the soil to keep together and prevent it eroding or getting washed away. And that the water is clearer in the sod afterwards. So you can really see how roots can protect against landslides and erosion. And I think that's pretty cool. And I'm always really impressed at how nature can show us the way and to do things in a simple and sustainable way. Like, it's really nice. But don't just look at this or learn when you come to the classroom. You should look out all around. Like, the world is your classroom. Have a look when you're coming to school or when you're going anywhere. See what's happening. Look at the rivers, how they flow. But not even just about erosion, but everything in general. All that we've done in the lesson plans over the last 4 weeks is try to give you the tools to learn how to work scientifically, to answer questions, solve problems, invent things. It's about having a question, a problem, coming up with ideas with your buddy or on your own or in a team, and then using what you know, testing things, testing materials, seeing what works for you and the situation, then coming up with an idea, writing it down and telling somebody else. This is what science is all about. It's about exploration in your minds, in your bodies, in your soul. Like, I'm actually excited doing this, and I've just poured water into muck. If you can get excited about simple things that, you do a study and you come up with an answer. And right now I'm excited, I can't even say the word, to chat a little bit more about water conservation in general and the things what you thought about all this. We're going to say hello again to Laura Nagel. Hey Laura, how are you?
Yeah, back again.
We've been in the lab, we've been working with some pretty nifty stuff, and it's just grass, looks good, feels good to walk on, and it's stopping erosion and cleaning water.
Yep, like most of nature, it evolved to do the perfect job, and we all know how important clean water is. I mean, people need to learn how to limit their impact on the natural cycle of the earth as it harms our animals and landscape.
So for everything we do and everything we make, we need to take care in how we do it.
Yeah, in order to look after all of that water, there's a large team of environmental engineers with loads of different people to making sure the process runs smoothly. The water goes through a filtration process and is then used to remove impurities from the chips and run different systems. So there are many different factors through all the stages of water usage and cycle at Intel, from it being taken to the campus, being cleaned, being used in the chip manufacturing, and then being safely returned to the river.
Okay, so let me get this straight. The big factory, lots of people working there, needs lots of water for the people, for also the making of the chips. The microchips, not the restaurant chips. Have you any idea of how they process all of that?
So here's a good bit of news. 87% of the water taken is returned to the river, which, as we saw from the experiment, it's very important as it means water can be used without disturbing the animals and fish that depend on it. Care for the environment and the earth is very important for the company, but it's really important for me too. I want to work in a company that makes the effort, and I'm glad to say that Intel has dedicated company goals to make sure this happens. For example, by 2020, they've returned billions of gallons of water. This process involves the work of a big team of people from all ranges of backgrounds.
I like that. So there you have it, like our little experiment inside and how it's working in real life in a massive world-leading company based right here in Ireland. That's cool. Thanks, Laura.
Thanks, Phil.
Well, that was a nice day, and what a nice experiment to end on. One that we got to build something inspired by nature and showing off how we can live in harmony with our environment if we take the right steps. Go on, the nature, showing us how it's done for billions of years. Speaking of which, now it's over to you. This year's Intel Mini Scientist was all about getting you started and highlighting the ways of how to work scientifically. Repeating this approach will have you solving problems and answering questions left, right, and centre. It's not just about science questions, remember. It's questions on anything. Science makes everything better. Our lesson plans and worksheets will stay free to download and try again, but they shouldn't be the limit of what you do. We've included some future work projects in them so that you can give them a go if you want to. Remember, you've already learned about charge, erosion, material testing, muscles, and how to make great jokes. Remember the banana one? The banana one? This is the one that I need to split in? Good times. Well, for me, maybe. But before I split, I want to thank you for taking the time to join us. And I hugely, strongly, and willfully encourage you to give all of our lesson plans a go and then take part in the Intel Mini Scientist again next year. It's all about giving it a go. Sometimes one good try and you'll never know where you might end up. That's the absolute joy of adventure and discovery, and that you can do it from your own home, your school, or wherever you choose to create your own testing facility.
Or on just a table.
Or on just a table. It's a testing table. Just remember, it's all in your nature. Thanks for joining us, and keep an eye out for more on the Intel Mini Scientist in the future. Farewell and good luck.